Okay, determine the points at which the function f of x is discontinuous. Well, looking at this over here, I'm going to say, we have to look at 3 because I'm looking at these things over here. 3 is the only problematic number. And what I want to do is write down, what f of 3 is. And that means x equals 3. It equals the number minus 9. The next thing I got to do is I got to do the limit as x approaches 3 from the left. Now, which one of those functions will allow you to do that? It's the top function. I'll write that down for you. And we'll do one at a time. We also want to do the limit as x approaches 3 from the right of that top function. It's the only function that allows me to do that. Now, these are absolute values. Makes it a little more complicated for me, but I'll write it down for you. Limit x goes to 3 from the left. Well, the top is always x minus 3. I want to go through this with you. X minus 3 is going to equal x minus 3 if x minus 3 is greater than or equal to 0. And it would equal 3 minus x if x minus 3 is less than 0. So let's take a look at it, and I'm looking at this from the left of it. And before I say anything, I want to just solve these inequalities over here. This is x greater than or equal to 3, all right? And what's this over here? This would be, let's see, x is less than 3. So I know it's complicated, but I want to focus in on what this thing over here says. It says you're below 3. This is the only one that would allow me to do that. What's that going to be? 3 minus x. That gives you minus 1, so this limit's just minus 1. All right? Let's do the next one. Limit x goes to, let's see, 3 from the right. The top is always x minus 3. And 3 from the right means this guy over here, which means the bottom's x minus 3. What does that give me? It gives me 1. So again, let's go back and read the question. It says determine the points at which the function is discontinuous, clearly at 3. And why is that? The left and right limits are not in agreement, and the function's value is not in agreement there. So let's just take a look at it. It's kind of jumping around, and let's take a look at that. So at x equals 3 is a jump discontinuity. Again, the function's value is minus 9. From the left it goes to minus 1, and from the right it goes to 1. You see this, you should look at the limits. We did do that, both left and right. And the function's value at x equals 3. A graph may also prove helpful in this one over here. Now granted, someone says, what do you mean by that? If you were to graph this guy out, I'm going to go through that right now with you. And I'm going to look at it. So at 3, I'll put this over here, I'll put this as 3. The function's value is going to be 9. All right? I'm sorry, it's not 9, it's minus 9. I'm going to erase the whole thing. So at 3, it's minus 9. Okay. Something happens at 3. All right, this is what we're talking about over here. And I want to claim over here is the function's pretty easy to look at. For example, to the left of 3, it's going to be minus 1. So I'm going to put this over here, and I'll put a little circle over here. And to the left, right, to the left of 3, it's minus 1. This looks like this over here. It goes on forever. Now to the right of 3, it's going to be plus 1. All right, what do you get there? Clearly a jump discontinuity. Thank you.